Why is this extremely simple problem given at interviews at Amazon, Apple, Google, Bloomberg, Microsoft, Facebook, Adobe, Oracle, Accenture, Uber, and pretty much everybody else? It's ranked as the most seen problem on LeetCode, and it's given to interns and first-round interviewers for a reason. It tests the most basic understanding of data structures and algorithm, and it's called toSum. To put it simply, I give you an array of integers of some length and a target, and your goal is to find two numbers within the array that add up to that target. So for example here, 2 and 15 add up to 17, not the target. 8 and -5 add up to -3, not the target. But 2 and 7 add up to 9, which means that you would return 0 and 0, 1, 2, 3, 4 for the index of 7. So you would return 0, 4. Now, how might a novice go about solving it? Well, the brute force solution is to just look at every pair of numbers within this array and see if they add up to the target. So we could start by looking at 2, and then we look at every other pair that can go with 2. So we would start at 211, well, that's 13, not the target. You could look at 215, that's 17, not the target. You look at 28, that's 10, not the target. But then you look at 2 and 7, see that that is the target, and subsequently you would return those two indices, 0 and 4. And this seems like a pretty good solution at first. But what if the size of the array is 100,000? Well, for every single integer in the array, of which there are 100,000, you have to check every other integer in the array, which is another 100,000. So that's going to come out to an astronomical number. It's going to take 10 billion operations just to find the numbers we're looking for. And as we get even larger, that just becomes beyond the scope of anything we could do within the life of the entire universe. We call this an order of n squared operation, meaning that for every n inputs to the function, you have to do n squared operations, which means it grows very quickly. While the solution is technically correct, if you were to give it in an interview, the very first thing they would say is, can we do it faster? And if you don't have an answer for them, well, don't expect a second interview. So let's talk about how to improve it. Well, the first thing you want to do is think about what operations do you not need to do. If we're looking at the number 11 and the target is 9, do we know what number we're looking for? Well, yes, it would be 9 minus 11, which equals -2, meaning what we're actually doing when we're looking at the number 11 is trying to see if the number -2 exists within the array. So the question is, can we confirm if a number exists in the array quickly? We can actually do this instantly with a data structure called a hash map. Now, if you don't know what this is, I highly recommend you look it up. I might have a video on it by now, but a hash map simply takes a key and maps it to some value. But what's really important is if you know the key of what you're looking for, you can check to see if that key exists within the hash map in O of 1 time. In other words, you can do it pretty much instantly. What if we took a hash map and we mapped every number in the array to the indices that it came from? In other words, we map 2 to 0 and 11 to 1, 15 to 2, 8 to 3, 7 to 4, and -5 to 5. We run through the array once, building this hash map. Then all we have to do for every I in the array, we'll call it nums, we just have to check to see if target minus nums of I exists within this hash map. Then we can just return I, as well as whatever I maps to. So we could say map of I. Is this faster? Well, we have to first run through the array once to build the hash map. Then we have to run through it again in order to check to see if its pair is in the array. So instead of going n squared times through the array, we're actually just going to go 2 of n. We're going to do 2 run-throughs of the array of size n. In other words, it's only order of n because we only take into account the variables. This is an entire order of magnitude faster, but we can go one step further. Now, the thing is that both returning 0 and 4 here and returning 4 and 0 here are both correct because it doesn't matter what order we return the indices, meaning that we can actually solve this in one pass. All we have to do is when we encounter a number, check to see if its pair is already in the hash map. If it isn't, then we put it in. If it is, then we return our answer. So let's run through this example. Let's start by checking 2. What is target minus nums of I? 9 minus 2 equals 7. Is 7 in the hash map? No, because the hash map is empty. So we'll go ahead and put 2 maps to 0. Then we'll check 11, and we'll see, does 9 minus 11 negative 2 exist in the hash map? No, so we'll go ahead and map 11 to 1. Then we'll check 15. Does 9 minus 15, which is negative 6, exist within the hash map? No, so 15 will map to 2. Then we'll check 8. Does 9 minus 8, which is 1, exist within the hash map? No, so we'll map 8 to 3. Then we'll check 7. Does 9 minus 7 equal 2 exist within the hash map? Yes, which means our solution, what we're going to instantly return, is going to be 4, 0, because 7 is in the 4th spot and 2 was in the 0th spot. So this is our answer. So let's go ahead and code this up. I'm doing it in C++, but it can be just as easily done in Python with a dictionary. The first thing we're going to need is that hash map. Now in C++, it's important to know the difference between a map and an unordered map. A map is going to be sorted, but inserting and checking is going to be slower. An unordered map is unsorted, but it's instant like we said before. So we're going to do unordered map, and what are we mapping? We're mapping the number to the indices that we found it, and we'll call it M. Then we just run through all the numbers. For int I equals 0, I is less than nums.size, I plus plus. So let's first check to see if we have a solution. So if in our map we find the target minus the current number, so if that does not equal m.end, that means it's in the hash map, then what do? We can just go ahead and return this solution. We can return the indices that we found, target of nums of I, and what else? Just I. Now, if we haven't found it, then what do we need to do? Well, in that case, we need to put it into the map. So map of nums of I equals I, just like that. And just because C++ is going to force us to return something, even though we already know there's an answer, we can just do something like that. So let's see if this works. And it does. So that is the most popular question in all of coding interviews, and I hope you understand it now.